All right, cool. Let's see. Can you guys see my AWS right here? Screen?
Yes, sir.
Okay, cool. All right, so what we're gonna do is, you can see here in the app, we go to the settings. So the database that we're using is a SQLite 3, and SQLite 3 is great. I think it's like the world's most commonly used database because it's in cell phones basically. So it's, you can see it's a file, it's file database. So very simple at that, from that perspective. Um, but there are limits to that, and scaling, and you have a large application, you're doing lots of complex things. SQLite 3 is not the best option. So what you're actually going to end up using in the real world, unless you're developing like for a phone or something like that, is Postgres or similar. But Postgres is free and works well. So we are going to use Postgres instead. But we're not going to just use Postgres. You guys have seen how to do this locally, right?
Yeah.
Okay, cool. But we're not going to use a local version of Postgres. We're actually going to use a cloud hosted Postgres. So what we're going to do is I'm going to go to AWS. I'm going to go to AWS and create a Postgres instance on the cloud. And then I'm going to get all the configuration for that and put it in here. And then after I do that, I'll be able to run this Django app locally using a database that's on the cloud. So that's where we're going to end up. It's just going to take a few minutes to set up. And then after that, I'm going to show you basically doing the same thing, but we're going to run Postgres on a Docker container. So the Docker container will be local, but so I'll say that everything that I'm going to show you now is going to be fairly tedious, and there's lots of steps involved. So don't try and like memorize all the steps or whatever. This is mostly about just exposing you to some different things, and hopefully we'll actually be using those things in the coming couple months or so. But for now, this is just an initial exposure. All right, so I don't want to use SQLite, so I'll come back to this in a minute. But first, I'm going to go log into AWS, and maybe I'll just do this off screen real quick. So you can create an account, and with AWS, if you create a new account, you get, I'm not advertising for AWS, but you get 12 months, and they have a free tier. So most of their, basically a lot of stuff that you could use, they have, you could rent very, very small, kind of underpowered things, but that are good enough for free. So I'd recommend creating an account AWS. Give me one sec. Okay, cool. So now I am logged in to the AWS, and if I just, so the first time you sign in, you're not going to see this recently visited, but AWS, if you click here for the services, they have a ton of things, and these are just like broad categories. They actually have like, it's kind of crazy how many things they have. Satellite, so you can, if you want to, oh, maybe you can't launch the satellite, but anyway. Um,
Hey, Chad, can you do a satellite tutorial later as well?
yeah, absolutely, yeah. Yeah, running Django on a satellite. All right. So what we're going to be concerned about now is something called RDS. So RDS is relational database service. So you don't need to know. So there's a ton of different services and a ton of acronyms. So it can be very overwhelming when you're looking at this, but just kind of watch me do it. So here, Amazon RDS. So this is where we can create a database. So I'm going to go create a database. By the way, in the real world, all of this, so this stuff I'm doing now is called infrastructure, basically. So this is kind of like DevOps stuff. We're creating all the resources that we're going to need and configuring them and all that. It's not really application development. That stuff is usually handled by some kind of automated tool. Has anyone heard of Terraform? If not, that's fine. So, like all this stuff that I'm about to do would usually just be described as like in a JSON object or something like that. So you don't want to have to, you can imagine if you have a large organization with lots of resources, you don't want to have someone, going through clicking a bunch of stuff all the time. But that's what we're going to do now. Okay, so create a database. So what I'm going to do is I'm going to create the world's least secure database. So you should not do this for anything even remotely important. But I'm going to make it as insecure as possible because it's easier to use. All right, so standard create. I'm going to do standard create because I'm going to have to basically downgrade some of the default security options. Okay, so engine options. So engine just means the database, basically. So Postgres, Amazon Aurora, MySQL, Oracle. You can use any of these, but I'm going to use Postgres. And then the version, I'm just going to leave whatever this default is. Shouldn't make a difference, but this is something that becomes important when you're developing applications. This is one reason why Docker exists. When you have a large scale application, you can't just be like, oh, whatever, we'll just use some random version of Postgres and it'll work out fine. So you really need to be specific about what you're doing. But in this case, we don't really care. So Postgres, that'll be fine. And then here's this free tier. So I recently created this account. So I have my free tier stuff. So I'm going to click this. And we're not going to be able to do any of that, which is fine. The database identifier, this doesn't really matter. This is just like a tag. So you can see what it is. So I'll just stick with database one. Okay, credentials. So here's the default kind of admin user for Postgres is Postgres. So I'm just going to leave that. And I'm also not going to do any secure stuff here, but we have to have a password. So I'm going to do an insecure password. And another one. In case you're wondering, the password is password. And then the instance configuration, I would just leave the default stuff here. You don't need to worry about this. Just leave that there. And then leave all the defaults here. That should be fine. I'm going to disable auto scaling. And then connectivity, don't connect. And it's going to create. So there's a bunch of, AWS stuff that you have to worry about, like virtual private clouds and security configurations and user permissions and stuff like that. I'm going to try and minimize that. Okay. Do public access. I'm going to click yes for public access. So this is going to, if I don't, then I'd have to, so what you want to do is no, because you don't want, in reality, you don't want someone just Joe Schmo on the internet to make a curl request to your database. So you would put this in a private network on the cloud, but then you would also have your application deployed on the cloud so that the application can talk to your database, but you can't access it through the regular internet. But for now, we're not going to do that. So again, this is all very, very insecure. So yes, for public access, that way we can access it easily. And then I'm going to go with the default security groups, availability zone. So this basically where is the physical server located? We don't care about that. And we don't need the proxy. I think that should be fine. I'm going to turn off the performance insights. All right, so that should be fine. And then here, estimated monthly costs. So the free tier is available for 12 months, each calendar month, the free tier, blah, blah. So this just goes through and tells you what the free tier is. So one side note is that if you, create an account, which I think ultimately we're going to end up using AWS for deploying our projects. But if you do it, set it up now, just make sure that you, one, just try to only use free stuff, and two, delete stuff when you're done using it. So you don't end up getting surprise charges. And especially if it's insecure, you can also have, if you create like a compute instance, like a server, and it's very insecure, people can hack into it and do, Bitcoin mining or whatever, which you have to pay for. All right, so create database. Okay, so this is gonna, so my, database, a Postgres database is being created right now. So this is gonna take a couple minutes. You can see the status is creating. That's gonna take a few minutes to get going. Meanwhile, I'll kind of skip ahead. There's gonna be an issue with access. So I'll just go ahead and we'll take a look at the database we've created. We can see, so the endpoint hasn't been created yet, but we do have a security group. So I'm going to go ahead and go to this VPC security groups because I'm going to have to change something to make it less secure. So I'll go here. And we have right here, so here's the security group. If you have lots of stuff, you might have more of these, but we just have one, and it was created by default when we created the Postgres instance. So we only have to worry about this one. So here, there's something called inbound rules. And this means like, I, on my local machine, want to access the Postgres instance, right? That's what I want to do. So the inbound rules by default, let's see. Oh, I must have changed this already. Okay. Let me just edit this. So I think it preserved my security group from when I was messing around with this earlier. But by default, you're only going to have this first one. And you're going to have to add another inbound rule that will basically allow incoming traffic from anywhere. And that's what this is right here. So this is all just kind of boring configuration stuff. If you want to try this out and you have issues, you feel free to ask me questions. All right, let's go back. So that should be good, hopefully. We'll go back here, and I'm going to look in the databases now, and I have this instance. It's still creating. So this probably is going to take a couple minutes. Okay, so meanwhile, I'll go to the Django. So I'm gonna have to change this configuration. So one, we're not using SQLite 3. We're gonna use Postgres SQL. And then the name is not going to be this. The name is going to be whatever. So this is going to be the database name, which we're going to have to create. So just like locally, if you want to create, your school's database, you have to go create the database first before you can use it. We'll have to do the same thing here, but we'll call this test DB. And we're going to have to pass some other properties as well. So one is user, and that should be Postgres. We'll take a look at all this stuff once the database is actually created. But so user, and then host. And we're gonna have to, we don't know what that is yet. We're gonna get an IP address once the database is created, and then port. So the default port for Postgres is 5432. So we'll do that. And I think that's all we need. Let's see if this is created yet. Okay, backing up, that's good. I think we need a password. And I'm just going to put that in right here, but in practice, you would use like an environment variables file here that you would put in your git ignore so it doesn't get pushed up, and then you would just read in the environment. But I'm just going to put this in here. So you'd never want to put, credentials in something that gets committed. So you would want to do like, os.getEnv and that. But we're going to do this for now, just for simplicity's sake, as a demo. And sorry, this takes a minute. Any questions while we wait for this?
So if you work for an organization that utilizes, well, the VA uses Azure or whatever that is, since they tied with Microsoft, but sure. If you were to create like your app or your project and then need a database backend, would you go to the infrastructure through IT to get that through them, or do they supply that for us, I guess, or can we create it on our own?
It would depend. It depends on your organization, but that's probably something that would be like a DevOps or IT infrastructure kind of responsibility. It depends on if you work for a very small startup or something like that, then the dev and the ops kind of get fuzzy. But for larger organizations, yeah, there's more. Probably if it's a normal organization, it'll take you 6 months after you make a request to get a resource.
Okay, so we wouldn't, like in a large organization, we would be getting this stuff elsewhere. We wouldn't be doing this on our own usually.
Yeah, it depends. You probably wouldn't be like creating a database like this. You might have to go in and take a look at it or something like that. if you're having, okay, so this is available now. But if you're troubleshooting, let's say you have a problem with the database and you're troubleshooting, you might have to go in. So we'll just do that now. The database identifier, and you can see. You can also set up more advanced logging, which is not set up here, but you can see if you're having issues. Let's say your end users are getting like timeouts or errors or something. You come in here and you see, oh, CPU is maxed out, or maybe there's a hung query, so that can happen sometimes. You have so the way databases work is like anytime someone wants to update or insert a record, they have to get a lock. And occasionally you have like conflicts where two things have locks, and it's basically like it creates basically a contradiction or something. And so your database can lock up, and then you have to go in and find the process ID and release the lock and blah blah blah. So, there's definitely some troubleshooting that you might have to do depending on what exactly your your role is and how big your organization is. The bigger it is, the less likely you are to have to mess around with stuff like this. Okay. So now that this is actually created, let me just double check the security group. It's using the same one. Okay. All right. So that should be fine. All right. We go here, and this is our instance. So the endpoint. So if we're running this on a local machine, that would be localhost, right? But here we're on the cloud, so we need an endpoint. So here we go. So the host, that goes right here. So not localhost, but this thing. And then the port is the same. This is the default Postgres port. So it's, unless you change it, that's what it's going to be. Okay, so that should be good. Let's try this out. So I'm going to get rid of this database, SQLite database, and I'm going to delete the migrations. All right, and I'll quit the server, and let's do Python manage.py run server. No, not run server. Let's do make migrations. Okay. So I'm using Postgres, so I'm gonna have to install psyopg2. So pip install psyopg2. Okay, make migrations. We'll see if this works. We got an error checking a consistent migration, blah, blah, blah. Okay. So this actually, reached out to that, the instance we have on AWS, and there's no test DB created, which makes sense because we haven't created it. So we're gonna have to create that. So I'll just open up a new, I'll split the window, I guess. So we're gonna have to make basically, we don't have direct access. We could get access, but I'm not gonna do that. So there's a command here. We can use PSQL. So PSQL, and then so I'm gonna paste this in. That's not it. All right, so we're basically here on our local machine, and we need to reach out to that remote hosted Postgres instance and create a database. So XU command there. So what I'm going to do is Postgres-u. So PSQL is the tool we're going to use to do that, which we use, we use to access our local Postgres instances, right? -u, this is going to be the username, and that is Postgres. This is the default kind of admin user, and we didn't change that. So we can look at the properties here. Let's see. I go to let's see if I can, if there's an easy let's see if I go to modify, it'll show me the properties. Password, username. Let me see. Well, it's not showing up there, but when I created it, I said to use the default, which is Postgres. So that's the username, and then H is going to be the host. So normally it would be localhost, but it's not going to be localhost. It's going to be that endpoint right here. And then -P is the port, which is 5432. So if I execute this, because I allowed access from the internet, which I should never do, it will ask me for my password. So I give it the password, PASSWORD. And now I'm inside of my cloud-hosted Postgres database. So I can do describe, didn't find any relations, which makes sense because I haven't done anything. So I'm going to create a database. So create database, and I'll call it testDB. Okay, so it created the database. Yeah, so this, let's see, T, no tables. Okay, anyway, this should work now. So I'm going to exit. And I'm going to try and rerun the migrations again. So make migrations. Okay, so I get no changes detected. I didn't get this error message, so this should work. So now I'm going to actually migrate. And notice that it takes a little longer. Okay. So now I'll create a super user, just like I've done normally. So Python manage.py create super user. And I'm going to run the server. And I'll go here. And I'm going to go to the admin terminal. So everything takes just a little bit longer because it's making a request over the network to validate the username. But I can still create posts. So everything should work the same. I'm just, instead of using a local database, I'm using that one. So save. Takes a second, but still works. And so now I'm going to go to posts. And I can see that that's actually there. So that is actually, this information is hosted remotely on the cloud on this this instance right here. So if I go to new, I can create a new one. So everything works. It just takes an extra second. So let me go to network. I'm not sure that it will show up here. But anyway, so that's how you can, use AWS to host your database. And, this way you don't have to worry about, I don't even have to have Postgres installed locally. I did run the PSQL command here, but you don't really have to have Postgres installed on your local machine in order to do this. Okay. Yeah. Any questions about that? So I'm going to go ahead and delete this resource. So actions, delete, leave. So I'm not going to use it anymore. So I'm done with it. So it's good to clean it up. But just so you should be aware of, as I kind of just showed you, anytime you create a resource like this, so this is a kind of a higher level resource. This is a managed service relational database. AWS will also kind of create a bunch of other stuff like security groups and virtual private networks and stuff like that. So I go to EC2, I think, let's see. You can also check. So EC2 is the actual like computer. So, the database runs on a computer. So even though I'm just creating a database, under the hood, Amazon is using other Amazon stuff to actually create that. There's VPC. Anyway, we don't have to worry about all this, but that was just a demo of what you can do in AWS. So now what I'm going to do is I'm going to do the same thing, but I'm going to use Docker. So I'm going to create a Dockerized version of Postgres. So I don't want to really get into this. This isn't going to be like a how to use Docker. This is more just exposure. I can talk more about Docker and like actually present it as a lecture later. But for now, this is just kind of exposure. So if you want to use Docker on a Mac, you install Docker Desktop, which is free and pretty easy to use. And then there's also on Windows, you can also do the same thing. Then on Linux, you can install it natively. Okay. So let's see, Docker Postgres. So the way that Docker works is they have images, which are basically, it's like a description of your environment and the application. It's kind of like a class, right? So you have a class, which is just a general description of how this should be, and then you actually run that container, which is like creating an instance of the container. And so there are often official images. So if you do a search for like Python or whatever, you'll see that there are different official ones. You can also just use your own. So typically when you create a Docker image, you'll start with some very low level, like just an operating system or something. And then you'll create your own image based on that. You'll download this base operating system and then install these packages and run this script and then do this. So that's kind of how it works. Okay, so here, Docker pull Postgres. This is gonna, if you execute this, it will use the latest. There's a implicit latest tag here. It'll download everything, all of the different layers or the different components of the image, and then you can run it on your local machine. And here are specific versions. So this is a Postgres. This is an official Postgres image. So we don't care about anything else. We just want something that has Postgres. And so we assume because it's an official image, this is well maintained and everything. And you can choose specific versions. So I want to run Postgres 3.9. And these other things are operating systems. So Alpine is a common one. This is a Linux flavor. It's like the most minimal possible operating system. Has almost nothing in it. And then, there's usually a large variety of different things. Anyway, so this it's kind of weird because I don't this isn't really a lecture on Docker, but it's new. So anyway, I apologize for the kind of confusion. So what I'm going to do is I'm going to go ahead and I'm going to look at the Docker containers that I have here. Let me get rid of this. So Docker images. This is a Docker command, and I can see that there are a few images installed on my system. So you don't need to worry about these other ones, but here's a Postgres container. So I'm just going to remove it so I can start from scratch. So Docker RMI, which means remove image, and then I can give it the image ID or part of it. So here's just like a random hash, basically. So you can pass it part of it, and as long as it's unique enough, it'll identify it. Okay, so it's telling me that it's being used by a running container. So the image, this is like a class. It's just like a abstract description. And then when I'm actually running a container, that's like an instance. So I can do Docker PS, and this will tell me all of the running containers. So this is, my last night as I was preparing for today. This is the image, which I didn't stop. So I'm going to stop this image. So Docker stop CD and Docker PS. So now I don't have any running Docker containers right now. I can also do Docker PS-A, and this will give me like all containers, including ones that are stopped. All right, so I'm gonna go back to Docker images, and I'm gonna remove this. So Docker RMI A2. Okay, so now I don't have this Postgres container in my local environment. So what I'm gonna do is I have this command right here, just for the sake of time. So Docker --rm. So the basic command I'm gonna execute is Docker run and then the image name. And if I don't have this Postgres image locally, it's going to download it first automatically. And then once it has the image, either from downloading it or because it was already here locally, it's just going to execute. There's a default entry point command for all these images. So it's just going to execute that, which is not really going to do anything. But so let's just see what happens. Unable to find it locally. So it's just going to download a bunch of stuff. And some images are going to require different kinds of configuration to run. So this one, it says, I got an error. So database is uninitialized and super user password is not specified. You must specify Postgres password to a non-empty value for the super user. For example, -e, Postgres password equals password. So any guesses as to what the -e means? What is the E short for? So if I do so I'll do this and then so it's an environment variable. So you have a bunch of environment variables on your machine. Here's one I just added for no reason. But in your bash profile, you also have a bunch set, and there's a bunch that come kind of by default. So here's a bunch of these environment variables, and what we're being told here in this error message is that in order to run this container, we need to pass this environment variable. So you can do that with run. So the basic command for run is this, so docker run and then the image name. And then in between run and the image name, you can just fill that up with a whole bunch of garbage that you need. So, so I'm going to do run Postgres and then -e. Might as well just copy this. Okay, and another thing we're going to have to do, which is a bit odd, is that I already have Postgres running on my local machine, right? And you should too, because we installed it, and then so it should just be running basically all the time on port 5432, waiting for requests. So the default is to run on 5432, and it's the same thing with Docker. The problem is that now I would have a Docker image running on 5432 and the Postgres instance running on 5432 on my local Postgres instance. So there's a conflict. So what I'm going to have to do is remap the ports. So there's another flag you can pass, which is -p, and then 54. So my on my local machine, I'll just do 30. I'll map that to the internal port 54, the default Postgres port. So I know this is a lot of stuff, but just roll with it. Okay. So now I've got 5432. So I'm going to go ahead and run that. And now I'm basically looking at the logs from inside the container. So I just ran the container. You can also execute the container with another flag, which is in detached mode, so you don't go into the shell, but that's fine for now. So I'm going to change this to 0, and this password, I think it was lowercase p. So I'm going to try running. I'm going to get rid of these migrations. All right, I'm going to open up another shell, and I'm going to do Python manage.py.
Don't you need to change the host in databases?
Oh, yes. Sorry, you're right. The host is going to be localhost. And we're going to get the same issue with the database. I just want to kind of go through the process here. But yeah, you're right. The host will be localhost now. So make migrations. And we get this same error that we saw when we were doing this on the remote Postgres instance. It's basically saying that the database doesn't exist. So we can execute that same command. So psql and then -u Postgres. It should just be the default user, although that can be configured. The default user, and then -h for host, which is going to be localhost, and then -p, which should be 5430, because I've mapped that port. So if I do this, I get asked for the password. So this is from my Docker container. The password is PASSWRD. Okay. So now I'm inside of this, so I can create the database just like I did with the remote Postgres instance. So create database test B. All right, so that's created. So now I'm going to exit. And so that should be set up. So if I run make migrations, I should be all good. And then Python manage.py migrate. Okay, so now I'm using this local containerized Postgres instance. So it's running on my local system, but it's really separate from the rest of my machine. And then I should be able to do the same thing here. So if I refresh this, I should see nothing. Let me go back. I think I need to run the server here. So I'll create another window, Python, and then I run server. Now I go here, and then I could go through the same process of, creating a super user and adding records and blah, blah, blah. But that's the idea. So that one, and I'll trash that one. But the kind of long and short of it is that we have like 3 different ways to do the same thing, right? So we can have a database hosted remotely. We can have a database running on Docker locally. We can also run it on Docker remotely. Yeah. So I'll talk more about Docker in the future. I just wanted to kind of introduce that and warm you up to the idea of hosting stuff remotely. All right. Any questions?
Could I perhaps get you to post the code that you did earlier today? I'm having a few errors, but I think if I can just look at it a few more times and stare at it, I might be able to get.
Yeah, for sure.